I'd like to first start by thanking the City of Martinez for hosting this workshop, and in particular Michael Chandler for his ongoing efforts to support waste prevention, recycling, and water conservation. So thanks to the city and to Michael. So with that, we're going to get started. As the title says, we've got enough to use, but none to waste. There's plenty of water in a sense, but we can't squander it. So I'm going to just jump right in. In the beginning, there was the earth, and it was good. And then came along Adam and Eve. They had a pretty good recipe. Well, it started out okay, but then it started raining and got a little wet. They continued on their little dance. And the next thing you know, their recipe worked pretty darn good. 7.2 billion of us on this planet and growing. And we're all drinking water, using water every day. And we're generating a lot of water waste and consuming that material. And as we all know, we're in the middle of one of the most severe droughts in the history of California. So it's time to conserve that material. The state of California and Governor Brown has declared a drought. So we'll just go over some of those facts just to kind of set the foundation here. First part of the year, he says, I've declared this an emergency and I'm calling all Californians to conserve water in every way possible. A few months later, on April 25th, he says, I call on every city, every community to reduce their water use by 20%. So he set a goal, a specific number for us all to achieve. Then recently, the end of last month, July 29th, the State Water Board approved regulations that went into effect that basically all Californians are expected to stop washing down their driveways and sidewalks, watering outdoor landscapes that cause excess runoff, and using a hose to wash a motor vehicle unless the hose is fitted with a shutoff nozzle, and using potable water in a fountain or decorative water feature unless the water is recirculated. So it's very specific, doable actions or practices. Locally, the Contra Costa Water District back in April has asked our local customers or residents to voluntarily conserve 15%. So it's 5% less than the state, but it's, again, a specific goal, 15%, and the city also is backing up that request by having the city council adopt a resolution for the same 15% voluntary reduction as part of their drought management program. So there we go with some of the specifics, some of the measurable goals. So let's kind of back this up. Where is our water coming from? Where do we get our water? Well, it starts with rain and snow, and the snow builds up in the Sierras, and then each spring we get the melt. The water runs down into the Great California Delta, and then early in the year, some of that water, that fresh rain or snow melt off, is diverted to the Los Vaqueros Reservoir. And that water feeds all of our local taps and faucets. So that's where the water comes from and how we store it currently. So now we know about our water. It's time for a pop quiz. You ready? So, how much water does the average single-family household in Contra Costa County use per day during the summer? And if you can understand the question, you do get a prize right off. Anybody have any idea how much water a single-family household uses during the summer? 200 gallons is the first guess? No? A little higher? 400 gallons? Still running a little bit low? 600 is the last call. No, we've exceeded it. The answer is 579 gallons per day in the peak of the summer. Like right now, we're using 579 gallons. So let's put that number into perspective as it relates to water use throughout the state and then regionally. Throughout the state, or rather in this case, did I miss one? In this case, in the state of California, on average, throughout the year, we're using 418 gallons statewide. That's a year-round average. So the summer use exceeds that. Outdoor use is the greatest consumption. We use 243 gallons a day, which is about 53% of our usage. And then indoor use is a little bit lower. 47% of our water use is indoor, and we're consuming 175 gallons. Now that's the statewide average. Fortunately, we have some data for Contra Costa County, more specific, and our number is a little bit lower than the statewide average. That's good. That number is 364 gallons per day. And it's an easy number for me to remember. It's one number shy of the number of days in the year, 365. So we use that many gallons per day, 364. Again, outdoor usage is the highest. We're using 58% outside, 42% or 153 gallons indoor. Now, you'll note in the lower right-hand corner there, winter use is lower because it's raining and less demand on our plants and irrigation, 190 gallons per day. And there's that 579 gallons per day number that was used in that quiz. That's the seasonal high. On average, though, 364 gallons. So that's the baseline. That's what we're using. So now what does that mean? What's the measurement? What it means is we need to really kind of take into our physical hands the understanding of how much water we use. 364 gallons a day equals, it's 132,860 gallons per year. Now, most of us know what a gallon looks like. I'm going to pass this around just to kind of give you a physical feeling. Imagine 132,000 of those things. It's a lot of water. Now, our 15% target is 55 gallons. What's interesting about that is today we're going to talk about rain barrels, and the common rain barrel is 55-gallon drum. So our daily goal is 55 gallons. Indoor it's 23 gallons, outdoor it's 32 gallons. These numbers are going to come into important here when I talk about how we're going to divert water from the indoors. Now here's a 55-gallon drum. That's your goal. Your daily goal is one of those drums. One of those drums diverted every day allows you to divert over 20,000 gallons a year. So that's impressive. This one diversion practice eliminates a huge amount of water. 20,000 of those gallons that you're holding in your hand right now. So here we go, another image of the drum. Every day on our 364 gallons of consumption, we consume 6.5 55-gallon drums. Imagine every single day a truck driving up and dropping off 6.5 drums of water. Okay, here you go, I'll see you tomorrow. And happening every single day. It's upwards of 2,400 of these are delivered to your home every day. So when you start to quantify this and put it into something tangible like a drum, you start to see it's a lot of water that we're consuming. So again, you see the image here at 6.5. Your goal is to take one of those out of that image right there. So who's using our water? Often industry, commercial industry, industrial, they're the source of a lot of consumption in our daily life. But in this instance, we, the individual resident and homeowner or single family dwelling, or in fact multifamily, and multifamily is on the short end, single family 52%. So that's the opportunity. There's the large gross consumer of our water. So let's jump in. We're going to get deeper now. We're going to get into gray water systems. What is gray water? Let's get into a very specific definition so that we satisfy the California Health and Safety Code as they describe it. So we'll just go through this. As defined by the California Health and Safety Code, it is, quote, untreated wastewater that has not been contaminated by any toilet discharge, has not been affected by infectious, contaminated, or unhealthy bodily wastes, and does not present a threat from contamination by unhelpful processing, manufacturing, or operating wastes. In a word, it's used water that's safe and it's not contaminated. And a little bit further, the code also specifies what household sources can provide gray water. And here's what's specified. Bathtubs, showers, bathroom wash basins, clothes washing machines, and laundry tubs. Any wastewater coming from kitchen sinks or dishwashers cannot be classified as gray water in California. Here is the California Plumbing Code that allows the use of gray water, and it's very specific. It says non-potable water reuse systems, basically in gray water systems. And here's the intent of this code. The California Code 16A says, the intent is to conserve water by facilitating greater reuse of laundry, shower, lavatory, and similar sources of discharge for irrigation and/or indoor use. 2, reduce the number of non-compliant gray water systems by making legal compliance easily achievable. 3, provide guidance for avoiding potentially unhealthful conditions. And 4, provide an alternative way to relieve stress on a private sewage disposal system by diverting this water to gray water. So it's very specific. It's it's kind of legal speak, but basically it's designed to make it easy for a household to divert some gray water for alternative use. So you ready? Another pop quiz. Which water source can be part of a gray water system and not require a permit? Here are your choices. A, bathtub. B, shower. C, clothes washer. D, bathroom sink. Or F, laundry sink. And everybody is saying what letter? C. They're saying C. You're correct. It's a clothes washer. So a clothes washer can divert the discharge water into your gray water system without requiring a permit. So that's important to know. And let's get into some math and show the value of diverting that water from your system. We can't see it very well, but what it says here is the average household uses or has 7 loads of laundry per week. That's a load a day. And each load on average is 36 gallons. Okay, and that adds up to over 13,392 gallons per year if you do a load a day. Now, not everybody does, but these are statewide data points, and so on average, the numbers show a load per day. What that means is if you divert your gray water system, that represents 10% of your total water use. So you're getting 10%. And remember, we've asked you to conserve 15%. Or 55 gallons per day. This is where you're really getting a payback on this gray water as it relates to your washing machine, your clothes washer. If you divert that, you are now at 65% of your 15% goal. Okay? So by simply diverting just one act, that being your clothes washer, you're doing 65% of your daily goal. It means you don't have much more to do in your day. So it's pretty impressive. Just well, that number is on average, which means the question is that number, that 36 gallons per day for high-efficiency washers? That number is the statewide average, which would take into account high-efficiency and low-efficiency appliances, okay? So here is the gray water systems language as specified in the gray water code. It says, clothes washing machines that do not alter the existing plumbing do not require a permit as long as these guidelines are followed. So you don't need a permit as long as you follow these rules. There's these do's and don't rules. So what you must do is you must have a valve to direct the flow between the sewer septic and a gray water system. Okay, you must have a valve to divert it either to the sewer or outside. You must have that valve or your gray water system labeled. The water you're sending, you must send the water to an irrigation system or discharge field outside. You must keep the water on the same property where the water is being generated. You can't let it go somewhere else other than your own property or that property. You must have a maintenance manual. Now that sounds scary, but a maintenance manual could be as simple as, remember you're going on vacation, you leave somebody a note on what to do, turn the lights off, lock the door, feed the cat. It's a simple thing as like how the valve works, where and how you can clean the system. So it can be a one-page document that you pin up on the wall where your system is designed. And we'll have some images of that shortly. And lastly, the discharge gray water must be under a 2-water cover of ground mulch. In other words, you trench it, you can have plastic shields or stones, and we're going to get into that. So again, lastly, the discharge gray water must be under a 2-inch cover of mulch, and you can have a plastic shield or stones. And we'll get into that in great detail. We've got some good images. What you cannot do, this is what you cannot do. You cannot use gray water or water from your wash machine used to clean diapers, dirty diaper water. So no fecal matter in the water. The water cannot contain hazardous chemicals, such as from a home photo lab. You cannot have pooling of the gray water, and it can't run off. So it can't just sit there, openly exposed, pooled, and it can't run off to adjacent properties. The gray water has to be accessible to people. It must not be accessible to people or pets, so it can't be in an open system or tub. It also cannot include a pump except for the pump that's in the washing machine. It cannot be connected to a potable water supply, and it cannot affect other parts of the building, such as the electrical or structural components. These all make good sense to me, okay? Here's the fine print. This is the actual code. So to make it easier, we can zoom. Okay, we're going to take a minute. You guys are going to read that? No, you're not. This is really just for legal purposes so that if you need to read this, when we post this publicly, you can read the fine print. Okay? For these systems that are using the clothes washer or the laundry, it's commonly called laundry to landscape. You can see there's a very simple image depicting how it works. You've got your clothes washer, you've got your levered system behind your washer, and then some plumbing to the outside and disbursement to different shrubs, trees, and plants on your property. So a very simple diagram of how the system works. And so we're going to get, kind of like peeling an onion here, we're going to get deeper and deeper into this. But overall, as long as you understand, it's pretty simple. You're taking the discharge water and you're dispersing it outside as long as you're not pooling the water. So it's pretty easy. So parts and pieces. What are the components of a typical gray water system? It's pretty simple. It always has a three-way valve. This valve allows you to control the water either into your typical sewer discharge or to turn the lever and discharge it outside into your disbursement field. So it has to have a three-way valve. It has to have an anti-siphon valve. And let me show you what one of those looks like. Very simple plastic gizmo. They're about $2 or $3 at your local giant big box hardware store. And I'll zoom in on that in a moment. So in addition to the siphon system, you have to have some pipes and plumbing to take that water from the back of your clothes washer, I keep saying that, from the back of your clothes washer and discharge it to your outside. So here's a close-up of a typical system. You can see on the left there a three-way valve. Normally the plumbing that comes out of the back of your washing machine is now connected or coupled to that three-way valve. You can then see the water goes to the left to your discharge into the wall, into the sewer system, or to the right where you see that valve, that anti-siphon valve up on the top there, and then it's being diverted outside. So it's a very simple system. And here is a kit that's available. No plugs here, but there are companies out there. This particular kit is sold for just about $100. They have several other kits that have more plumbing supplies with it. And if you Google gray water systems, you'll find these systems available. If you're kind of a do-it-yourselfer, you can certainly build a system for well under $100. The most expensive component in your system is that three-way valve. It can be anywhere from $15 to $40 depending on what it's made of and who you're buying it from. There is your close-up of the three-way valve, which again, you have water coming in from your washing machine, and then you're diverting it either back to your sewer typically or off to your gray water system. There's a close-up of that in-valve vent or anti-siphon. That's important. It's required. You must have that device in there. And here's a close-up. This particular system, unlike the other image, has the anti-siphon plumbed on the outside. It doesn't matter where you have that as long as it's above the highest point on your discharge system and it works properly. So again, this can be sited indoor or out. And they felt, for whatever reason, it's easy for them to get to that valve right there. If for some reason it clogged up, they can get to it readily. Here's another close-up of the valve. And remember, one of the requirements was to have a maintenance and a maintenance guide and proper labeling. It doesn't have to be fancy. You notice in that kit they had a professionally made sticker. You don't have to have that. Obviously, just some painter's blue tape here and a black marker saying here, in this case, they must have a bamboo garden. So they're discharging their water off to the bamboo, or if for some reason they wanted to divert it back to their sewer system, they just turn it to the left and the water goes back on your normal system there. This is a very important thing to pay attention to. Two things for just the safety and the ongoing maintenance of your system. Number one, you want to anchor your system. As you know, when the machine is operating, sometimes the wall or the floor vibrates. If at some point the plumbing came apart, you'd have a real mess in your house. You don't want to damage your building there. So you want to always anchor the system to the wall. And what you do is you take a small block, you mount that block to the stud, and then you mount the system to that stud. So it's very simple, not very, not overly sophisticated here. So you mount the system to the wall, and then the one place that requires a clamp is where the hose coming out of the clothes washer couples into the three-way valve. You've got to put a clamp there, because there's some pressure coming out from the pump into that three-way valve. If that thing ever blew off, you'd have a real problem there. So that's the one spot you want to couple. Everything else can be either glued or friction fitted, but right there where it comes in from the machine, you want to have a hose clamp in there. All right? This shows now that you've made your system on the inside, you now need to plumb it to the outside. So they've brought the pipe outside to the backyard or side yard. Now, an important thing to be aware of, specified in the requirements, when you're drilling holes, you just don't go willy-nilly. You want to make sure you're not hitting a structural support, that you're not hitting any pipes or plumbing, and you're not hitting anything electrical. So you need to be careful with that. You might do some pilot holes or get somebody that knows what they're doing to start putting a hole in your building. Another tip is when you are ready to drill that hole, don't just drill straight through from one side to the other. Drill from both sides. So go outside, start that hole on the outside, go in, then go back inside and start the hole on the opposite side and drill in. If you just drill from one side all the way through, when you get to the opposite side, it's going to kind of blow out and you'll have a sloppy, messy hole. So you'll blow up your drywall or you'll blow up your stucco there. So you want to kind of make sure you do a clean hole right there. And as you can see, they've got their PVC pipe there ready to go and couple in there. Another important fact, you always want to make sure all your plumbing is 1 inch or greater. Anything less than that, you stand a chance of it clogging up with any debris coming in out of your gray water from your clothes washer. So having a 1 inch plumbing system is sufficient for ongoing operation. So that's important. So once you've made your levered system on the inside of your house and you've plumbed it outside your wall, now it's time to get outside and start laying the line, laying the plumbing or the piping for outside. So here you can see this particular system is doing the same thing. They've got their inline vent outside. For whatever reason, they're preferring to do it that way. And then you see it's teeing off, going out to what we call some discharge points, or some discharge or drip points within your field of disbursement, and we'll talk about that as we go in. Now, this particular image technically doesn't satisfy the requirements, which are you must put your pipes under 2 inches, bury it 2 inches, but I selected this so you can see how it's done. You see the inch pipe coming out, and then you see a lateral going out to a discharge point within your water system, and I'll get into that further. But so you run your main line, and then you have laterals coming off your 1 inch line throughout your property. Okay, so now this particular installation, they've trenched around, and now they're covering up their inch lines. So it's not that sophisticated. You make your plan, you drop your line, and you get in. Here's another one. You can see to the lower right, they're coming off the wall, and they've junctioned it down to the ground. You can see they've trenched it a good, looks like 20, 25 feet, ready to go. They can have laterals as many as they want coming off that line, and then they'll cover that up. Okay, so it takes a little bit of work up front. This system here, you can see they've already buried their lines, and they've chosen to use mulch to cover the material instead of some of these plastic shields. The plastic shields allow you to identify where your discharge points are. So this is my preferred approach. So you could have several of these throughout your property. All right, so wherever those discharge points are, you're able to go and periodically, you can just lift up the cover and make sure that when the system's running water, that water is coming out of those release points. Here's another example. Again, it's teed into that plastic shield area, and it's covered up, and you just lift that cover to take a look. Here's a commercial valve chamber here. You can see on the bottom right there, the pipe's coming in there. It's a little damp in the bottom of that well there, so you can see that it's open and flowing. Here is a nice, handsome, completed installation. They've laid the pipe, they've covered it up, and you can see the access point right there. That you could have several of those throughout your property. This one here, a little more simple than the commercial. They've got looks like she's using a piece of terracotta to cover up her excess port right there. So you can go in and periodically just inspect it to make sure that there's no blockage or plumbing. Another thing, you never want to block any of your discharge points. It's always a completely open system. If that were to be blocked up, it would back up into your house and cause some serious water damage. So those are some examples of the shields. This particular one, the resolution of this image is very low, but it's a very interesting design. You can see what's going on here. They've got their 1-inch pipe coming into just a typical 5-gallon bucket. And then from that bucket, they put out kind of a star system, some smaller, probably 1/2-inch, 3/4-inch pipes in 6 points. And then if you note, it's in a round trench. And at the end of each of those 6 laterals, it looks like they're digging a hole for a tree or a shrub. And at the tip of those laterals, you can't see it in this image from here, but there's some chicken wire in there, so they can keep the discharge point or the flow point open. Once they've installed that star disbursement system, they'll cover all that up with the exception of the top of that barrel, and they'll be able to discharge to 6 points all at once. So that's a pretty clever system. Here's a top view of that. So again, it's reuse. It's real simple. Just an 1-inch+ pipe going into a 5-gallon bucket. As that fills up, the water drains off to those 6 discharge points. So a very clever way of dispersing water. Shield systems you saw in those earlier images, different types or different shapes. So here these are commercial valve covers. You've seen these all around in standard irrigation systems. Here's an open top rectangular. If you're wanting to have a large disbursement field, here's a conical one you can see to the lower left, just an open hole. This image right here shows you kind of a cutaway engineering view of it, how this works. So you can plumb that in the ground, and then it's got the removable lid so you can have access to your drip points there. I like this one, it's my favorite, because it's simply a flower pot. And a lot of us save these pots, so this is an opportunity for reuse. So a simple green one or a black one, what you'd want to do is take some sort of knife or whatever, and you would cut, on, in this case, the bottom. You could maybe cut 3/4 of it off to make a flap. If you remember on some of those other images, you saw it kind of flapping back. They're reusing a flower pot here, so you would cut that and you would flip this upside down. So the top would be the bottom, and then that flap would just stay on, and you just bury that into your system. So it's cheap, maybe it's free. You've got 1 or 5 of these laying around. So it's a great way to make your little plastic shields. So now that you've got your system installed, you want to pay attention to the water and your cleaning solutions. So you don't just use any old soap and water. You want to make sure that you don't harm or kill your plants with certain soaps. So we'll walk through this. So you want to choose plant-friendly products are key when using a gray water system. So you need to go out and read the labels and replace perhaps what you're currently using. All the products should be biodegradable and non-toxic. That kind of seems obvious. This is the important part. They should be free of salts or sodium and boron or the brand borax. Okay, so no salts and no boron. 2 common ingredients which are non-toxic to people but are harmful to plants and to the soil. So you just want to read the labels, no salts and no borons. If you use any kind of chlorine or bleach cleaners, those are harmful to plants, and they should be diverted back to your sewer system away from your gray water system, because or any other, what does it say? Let me read this. Chlorine bleach is also harmful to plants and should be diverted with any other harmful products to the sewer or septic by switching the 3-way valve. So if you're going to use that, then you just need to be aware of it. Throw the valve back to the sewer system and go ahead and use your more toxic or chemical-based cleaning products. Hydrogen peroxide bleaches are less harmful. You may want to do your research on that, and can be used instead of chlorine. So there's some more alternative cleaners out there. So you want to pay attention to that. So even further, Another consideration when using cleaning and beauty products is their effect on the pH of the water. Most soaps do not change the pH, but some do, so you need to get kind of into the science of your soaps. In general, liquid soaps do not change the pH, while bar soaps make the water very basic as opposed to acidic. So in that case, because we're not using, let's say, water from the shower or tub, we don't really need to worry about that. But if in some way in your clothes washing system you're using some bar soap, you may need to attend to the acidity of that. Certain acid-loving plants may not be happy with this kind of basic water, so you need to just be aware of that. Talk to a nursery person or discharge the water to the appropriate plants. So you get into some gardening decisions. And if you're not sure if the pH is affecting, choose plants that are not acid-loving. So you may need to replace some plants, or as I said, choose where you're dispersing this water. So those are some critical things. So it's really important to pay attention to the soaps that you're going to use when you put in one of these systems. So here we have some brands to choose from. We're not condoning any of these. And you can easily find these brands by just typing in gray water system soaps. And that's where I got this. I found these on several other websites, and so I just wrote up this list. So there are common brands. Most of you are familiar with these. We won't get into the names here. So in closing on this, here's some images of a very mature system. You can see all the plants are thriving, and you can see all those access points in the covers. And then this one is even more so. You don't even see they've camoed out. Maybe they've buried their discharge points within their gray water garden. So I'd like to stop now and take any questions that you've had relative to the gray water systems. Yes. The question is, it's required to have a pump, or it's required that you don't have a pump for gray water system. The comment is their property, their washing machine is lower than the outside property. How do you deal with that? Well, that's a challenge. You cannot have a pump system. You may need to discharge it to another area, or you may not be able to physically have a gray water system on that particular property, because in order to meet the requirements, you cannot have a pump other than the pump that's on your washing machine.
Is that a requirement of the system or the permitting process?
That is a requirement of the California Plumbing Code 16A, that you cannot have any other pump other than the one that's on the washing machine. Let me restate that. You may not operate a non-permitted system with a pump other than the pump that's on the washing machine. Now, you could go out and get a pump. So for properties that have their ground above the clothes washer, you would have to then get a permit to allow the use of a pump. Thank you. The question is, what's going on in terms of commercial or industrial water discharge, and are there any pressures on them to reuse water like we're proposing or promoting here in terms of gray water systems? First, I don't know what type of legislation or requirements are out there. That's a great question. I just haven't pursued that answer. But I am aware there are many companies that are proactive and environmentally conscious and do have water reuse systems within their manufacturing process or within their general operation systems. It makes good sense, one, because they save money. So they're looking at the economics of it, as well as being able to take advantage of the environmental benefits to say we recycle our water. Yes? Are there any restrictions on the use of gray water use on edible landscaping? No, there are not. That's why this particular water, and the definition of gray water, they specifically picked several appliances or places in your home where gray water comes from. And as we mentioned, they've excluded the kitchen water, basically, in dishwashing systems because of potential biota in that water. The other water, once it's filtered out through the soil, has no harm to you or your plants. The question or the comment is he's heard that gray water turns into black water if stored for longer than 1 day. And that's true because, and that's one of the primary criteria, is that the water cannot pool or stand or be in any sort of a tub, that it has to discharge immediately into your property to avoid that whole biological condition. It will go from an aerobic situation to an anaerobic condition, which is unhealthy. So that's true. The comment is from somebody that has a gray water system that for ease of installation or design, that the temptation is to have your discharge points close to the home or property walls, and that's not advisable because you have long on-term water potential or potentially ongoing water damage to your foundation. Yes, it's safe. It wouldn't be permitted. The codes and standards are designed and set in such a way that it's for your safety. So if you recall, there was lots of words of healthy, all these things in the language itself. The code specifically takes those concerns into account. So yes, it's safe to use that water because it's going through the ground, it's percolating through the ground into the soil, and then the root system's taking it up. It's not like anything that might be bad in the water is jumping into the air into your plants. So it's able to percolate through the groundwater or through the ground and be absorbed. So yes, it's safe because it's not standing and becoming unhealthy. All right, well, let's continue. Let's focus on